So I think we should wait a couple more minutes for other people to arrive. I think. So how many people here use Polkadot? We've been building a lot, but how many people actually use it? Yeah. What do you, yeah, staking. Okay, what else? Apart from staking, what else can we do on Polkadot? Like the relay chain and the encompassing. Running parachains. Okay. Governance? Identities? Yeah. Okay. DeFi? Not really? Okay. There's a whole bunch of use cases, so we'll, yeah, I think we should start. So before we go into XCM, this is just going to be a brief introduction to Dapps, and then Nikos, another Parity engineer, will be talking more about light clients after this introduction. So introduction to Dapps. So we'll explore what is a Dapp firstly, how they communicate with Substrate runtime. So this will be revision from last week's assignment and everything. Interacting with web extensions, critical piece for Dapps. Working with Polkadot JS API, and then further how to construct transactions with that API. And then we'll go into some optimization stuff and some miscellaneous dimensions. So Dapps really put everything we've been working on together. It's the means for humans to interact with chains. Dapps do this. So what is a Dapp? So here's a few examples. This is Moonbeam's dashboard. They've opted for like an all-in-one interface that handles staking, governance, across-chain transfers. Hydra DX. Has anyone here swapped tokens using Hydra DX? Cameron, good. This is like the flagship swapping interface right now on Polkadot. There are a few others. Yeah, Interlay is an interesting one. We can swap here as well, but Interlay is primarily for DeFi for Bitcoin. So I can lock Bitcoin in a vault, and then in return I get something called IBTC, Interlay BTC, and then that's like a derivative of my locked Bitcoin, and then we can then use that to trade and whatnot. It's quite an interesting one. So you might be wondering, how are these vaults decentralized? If I lock my Bitcoin in a vault, well, they're collateralized. So the vault operators need to collateralize their vaults before we can deposit that Bitcoin. So not all dApps are great. Like this UX sucks, but this is another one. PokerSwap, like another swapping interface. So the spectrum of quality between dApps varies. So that's a good example. And there's staking dashboard. So fully featured dashboard for nomination pools and direct or solo staking, we call it, on the relay chain. Okay, so there's no strict definition for what a Dapp is, but they have certain characteristics. Account management is popular using cryptographic primitives. SR2119 is probably the most popular way to do that. Yeah, interaction with a node or a decentralized network. They tend not to be reliant on centralized APIs. So the key word there is reliant. So they could have them as a part of their feature set, but they should work without those APIs as well. Yeah, allow signing and submitting, interacting with the blockchain node. So here's a question. Is a Dapp a Dapp if it's hosted via traditional web hosting versus something like IPFS? Yeah. So that's the consensus today. Even though traditional web hosting is somewhat centralized, we still consider a Dapp by this means. So yeah, does a Dapp need to be open source to be a Dapp? What do you think? Yeah. It's not required. I mean, we need kind of guarantees that it is indeed like a Dapp, like it's connecting to the node and whatnot, and sometimes it needs to be open source to verify this. So with that said, yes, a web extension is a Dapp. Nova Wallet, not really a Dapp, it's more like a platform, but they have Dapps embedded in that platform. So in the browser tab, I can go ahead and connect to web-based Dapps on that. Ledger Live, they have things like transfers, account creation, but again, it relies on historical data from centralized API endpoints, and as you can see, an update is being downloaded there from an external service, so not strictly a dApp. Polkadot Vault. I personally feel Polkadot Vault is the best hardware wallet in terms of UX right now. I prefer it to Ledger, so yeah, I would say Polkadot Vault is also a dApp. It doesn't interact directly to nodes, but it does via QR codes and whatnot. Subscan. No, Subscan's not really a dApp. You could argue the backend, that's scraping the data and stuff from the node is a dApp, but that's not the public-facing interaction. And again, PokeAssembly is a similar story. It's a platform. So in general, the more decentralized, it's a very broad term, an application is, the more it's considered a dApp. Yeah, it doesn't necessarily need to be connected to a node. So Polkadot Vault, again, is a good example of this. So if the app can function with all the centralized APIs turned off, then it is more likely to be considered a dApp. It's a good metric for measuring how good it is. Yeah, there's no strict form factor. And dApps are becoming increasingly technical. The more decentralized you want to get, the more technical they're becoming. So, we're not dealing with, static landing pages and WordPress blogs and things. These are becoming more technical. Yeah. So dApps are more suited to agile development, especially in the Polkadot ecosystem where we can upgrade our chains. They evolve and improve over time. So as such, dApps should be treated in the same manner. I've seen this mistake being made a few times where like a waterfall approach is taken, rush to launch a dApp and then kind of forget about it. So this isn't the best thing to do there. So value proposition. What gives value to a dApp? Well, maximally resilient, or how decentralized is the most important thing. Otherwise, why are we doing what we're doing on the node side if we cannot deliver that experience in a decentralized way as well? Easy to understand and use, something that some projects struggle with in the ecosystem, but this is a key point. In-demand use case, staking governance seems to be the flagship ones on Polkadot right now. Yeah, offers real utility to the chain, like securing the network, stability, and 24/7 uptime. So this is an important one. We expect the node to be running 24/7, unless it's something like Solana. So we expect the dApps also to be available 24/7 and be reliable. So this is a common misconception. We do not need like the latest and greatest JavaScript framework to give value to a dApp. So there seem to be JavaScript frameworks coming out every few days these days, and even though they might have some 10% faster, but they only have like 2 maintainers and a very small footprint in the ecosystem, it's not the best decision. So stick with mature frameworks in their summers, and React is the one that I opt to use. Yeah, I might be being a bit too harsh here, but because, has anyone seen the dead airdrop, the dead meme coin? So things like this are bringing attention to the ecosystem, so that's a bonus. But in general, we want to have like long-term value propositions. Okay, so just a brief look at the tech stack of a dApp today. So yeah, TypeScript. We don't need to cover the difference between TypeScript and JavaScript, do we? Superset of JavaScript provides typing, extends JavaScript with a JS framework, React, and whatnot, and a toolchain. So I've highlighted the ones I personally use. That's pronounced Vite. If you're bootstrapping an app very quickly, Create React App is a good option. That's how Staking Dashboard started. Yeah, and Webpack as well. We rely on package managers. In the Rust space, we rely on Cargo, but in the JavaScript world, NPM, Yarn, PNPM. Yeah, linting to maintain consistent conventions across the code base is important as well. Again, cargo formats on the palette side. We use things like ESLint on the JavaScript side. Yep, heavy reliance on GitHub CI, so things for releasing, staging, things like this. Automated release. Google have released a good tool called Release Please. So every time a PR is merged, it will update a release PR with that merged PR, and then when you merge the release, it will go ahead and create a GitHub release. For desktop, Electron is probably the best framework to go to right now, purely because we don't have access to web extensions. So instead, we rely on hardware wallets, and Ledger provide APIs out of the box to connect to like Electron apps as well. Yeah, and testing frameworks. Because we are not relying on like maintaining a $7 billion market cap with the Dapps, that this is the node's responsibility. Testing is not usually as comprehensive, let's say, as the protocol side. So testing frameworks vary and practices vary as well. Yeah, and we also obviously need an API to connect to the network. It's not very common to use the JSON RPC directly when connecting to nodes, so Polkadot.js API is the most common one to use. Yeah. Where's the mic?
Like so far, you just outlined basically a generic tech stack. Is there anything here that is like specific to like that development? Like, cause it's this is a
no, this is
a tech stack.
Yeah, this is the stack. This is the stack. Yeah, the API is.
It's a generic tech stack. Like
it's a generic tech stack. Yeah.
There's
Contemporary.
nothing here that's like specific to Dapps.
No. Well, the API, I guess, is
the API.
But static again, bundle, and then we get into like decentralized storage. But
so in theory, like you could use like instead of TypeScript React, you could use like Flutter or
exactly. Yeah, you could. Yeah. Standard markup as well. Okay. All right. So this section is a bit of revision from last week. So how do Dapps communicate with Substrate runtimes? So firstly, we need to know the metadata. We need to know this to interact with the chain. So yeah, a chain's metadata describes everything about it, what's available storage-wise, constants, calls, and the types used. So once this is known, APIs can go ahead and query those types, that state, and etc. And they will know what transactions to submit. So we can either fetch this metadata dynamically, this is what Polkadot.js API does, or we can store it statically if we so choose. So is there any particular reason we would want to store metadata statically, like in a JSON file in our Dapp, rather than rely on the API to fetch it? Can anyone think of a good reason why we'd do this? Is there a mic somewhere?
Yeah, it is good on the static analysis while you know which type of data are you interacting with at the moment while you're doing programming. So it's good.
Yeah, like visualizer, that's a good point, something I missed out. So if your Dapp is designed for one runtime version, which is probably not the best idea because we're constantly upgrading, then you might want to opt for a static one. And obviously, like you say, it's local in our bundle, so it can load as well as the bundle's loading. Yep, so there's various ways we can interact with our runtimes, system-related information like the blocks coming in, like chain storage, runtime constants, runtime APIs. Did anyone implement a runtime API for their assignment? Great. So functions that are executed in your runtime. Yeah, transaction submission as well. So everything that's annotated with the palette constants macro is exposed to your metadata. So here's a few staking related constants. Here are the runtime values being applied to them. and then they become available to query through the JSON RPC. So the same ones here. Okay. So a similar situation with storage values with the palette storage macro. Same situation. So very easy to, just to query what the current chain state is. So interesting question. Why might opting to use, a storage value make more sense than a constant? So we always have this trade-off to make. Can anyone think of good reasons to opt for storage value? Sorry? Exactly. So it can easily be updated with governance. I mean, we could update the entire runtime blob, but this is a much bigger deal than updating a single storage value. So a good example here is with nomination pools. When we rolled the initial release out, I think we had a maximum of 64 pools, I think it was. Same with pool members, I think there was a cap, maybe 512. So when we were more confident, we pushed up those storage values over time. So yeah, runtime calls, functions that act more like traditional APIs, defined in your palette, they have full access to your palette config. So again, like runtime nomination pools use this for fetching pending rewards and to also convert between points and balance. So when I bond dot in a nomination pool, what actually happens is points are minted, and those points represent your balance. So rather than having this logic, on the Dapps side, it probably makes more sense to keep it on your palette side. This is an example, so it's more of like a traditional function, rather than pointing to a storage key. Yeah, covered most of this. Yeah, additional calculations, type conversions, key generation and decoding, lightweight computation. Okay, so yeah. Dapps generally need to know metadata to communicate with the chain. Yeah, chain level info, constant storage items, runtime calls. All ways we can communicate with runtime. So Substrate exposes, HTTP and WebSocket endpoints, and as we learned from Anka, it implements the JSON RPC protocol. This is the primary means we can communicate. Yeah, and all of these should be supported in a good API. Okay. So interacting with web extensions. Web extensions are, I would say, a necessary evil right now. They're required to, create accounts, manage my interactions, but they're a bit of a pain to work with. If the extension is updated and it breaks, then people blame your Dapp for breaking instead. They all need to adhere to the same API, and obviously everyone is a separate extension with a separate user experience, but they're not the best, but it's what we have right now. So how do we interact with them? Well, they're injected into the window object in the browser. Everyone is keyed with like a snake-cased ID, and they all should have an enable function. So the enable function needs to be called, and then we have access to the API of the extension. Okay, so yep, the web extension is injected into window.injectedWeb3. Yep, this is an asynchronous process, by the way. There's no guarantee these things will be ready when your Dapp calls them, but they're usually injected pretty quickly. So yeah, another issue with web extensions, browser compatibility, commonly used with Brave and Chrome, Firefox maybe as well, but in general, Chrome is the dominant browser here. So we call enable to retrieve the extension API, and this is the point at which all the pop-ups happen, right? So we approve, and then the Dapp is able to retrieve the accounts and the signer as well to sign transactions. So again, there's no guarantee these APIs will be available for every extension, so we can actually check if there is a property called subscribe or whatnot, and if there's not, maybe we can fall back to support, accounts.get, which is just a query to get the accounts. So yeah, who's experienced this before, this issue here, the pop-up issue? Yeah, it's quite a common issue, and it's mostly because of a package called Polkadot extension Dapps. So install it via NPM, and you get some utilities to interact with web extensions. But as an opinionated decision, they decided to pop up every active extension installed, rather than allowing the user to choose one. So this, in my opinion, is an anti-pattern. Should be avoided. Okay, so yeah, this is where we access the extensions from, window injected Web3. Web extensions are unpredictable, and they might break. So this has happened on multiple occasions with the staking dashboard. Yeah, necessary evil for Dapps until we figure out something a lot more user-friendly. But we can also support external ways to interact with accounts, like hardware wallets, Ledger, Polkadot Vault, and Wallet Connect protocol as well. So Dapps can support other means in the app, but web extensions are still the primary way. So yeah, avoid this if you can. We're working on an alternative, but called Polkadot Cloud React. It's a library of React components, but this is still in beta. So just a reference piece there. So Polkadot.js API. Go through some basics. So it's a JS API and kind of a TypeScript one. The TypeScript support is there, but the types are usually hard to find in packages, but it's there. Yeah, it dynamically fetches the chain metadata as we're connecting to the API, so we don't actually need to worry about dealing with that it's dealt with under the hood. So automatically fetches the metadata for you. It provides helpers for decoding, because API results, we need to decode them from scale and whatnot. So, yeah. That might not necessarily be true because the JSON RPC will return a JSON object instead, but okay. Can Sean or Ankan confirm that? Does Polkadot.js API fetch JSON results, or does it fetch scale encoded results? Okay. Okay. Cool. Okay, fetches scale. Okay. So Polkadot.js will handle that under the hood and decode that. Yeah, WebSocket, HTTP interface support. And it supports the light client as well, Substrate Connect. Yeah, it's the only production-ready API today. There are some others being worked on, but that Nikos will probably talk about this later on, but Polkadot.js API is the only production-ready. So connecting to a chain, it's quite simple. Just support import two objects here, and in this case, I'm importing the WebSocket provider. I give the node endpoint here, and then at the bottom, we can just create an API instance from the provider. So as we can see, the API is this is asynchronous, so we're awaiting the API promise create method here to finish. Why might this be? Anyone hazard a guess? It's because like I said, we're fetching that metadata from the chain. We're populating the API with all the types and all the various calls and things we can interact with. So high-level namespaces for the API. So the RPC, API.RPC, gives us access pretty much to the whole JSON RPC. API query, get storage items. API.consts, runtime constants. Then we have API.call. These are like runtime APIs. And there's an interesting one called derive. And these are like hard-coded that combine various queries and consts to derive a value. So shortcuts, really. So formatting results as results come in, as Ankan and Sean confirm scale encoded. So Polkadot.js provides helpers to format results into different formats, like JavaScript primitives, depending on the type returned. So some common ones, to number, to JSON, to string, self-explanatory. And then there's a weird one called toHuman. So these are all available depending on the type returned. toHuman is like a human-readable representation. This is what the docs state. So usually toHuman formats results to strings. So if I wanted to format a number using toHuman, it would probably be like a comma-separated formatted string. Okay. Yeah, so in general, it's safer to format balances as strings as numbers may overflow. So Polkadot's unit of precision is 10 units, and JavaScript only handles numbers of 8 bytes, I believe. So yeah, numbers should be handled as strings and then passed into another utility like BigNumber.js or BN.js to handle those. Okay, subscriptions, very useful feature. We can subscribe to a query and provide a callback function, which is executed every time an update happens on chain. So here I'm subscribing to system.account of an address, and what is returned is the nonce and the various balances of this account. So every time this changes on chain, our callback function is executed. So what is returned here is an unsub object. And when I'm done with my subscription, I can just go ahead and call this. This is a function. So I call this, and then I unsubscribe. So quite important for tidy up. I can also provide an array of queries and use a utility called query multi. So in the callback now, an array of results is provided, and I can handle them in the callback function. That's quite useful. So entries is another feature. For example, if I want to fetch every entry of a storage item, I can go ahead and do this. So api.query, the palette name, the storage item, .entries. So in this case, I'm fetching every single nomination pool entry. And this is an entry in the literal sense of the term, as in a JavaScript entries object. So you could then wrap this in from entries and format it into an object. Yeah. So we can also fetch a subset of entries that are double maps. So storage items that are double maps, we can give the key using .keys in this case, and then a subset is returned. These are not subscriptions. These are just like one-shot calls. Okay. Yep. I believe this is an era. The era, I'm fetching all of the slashes, yeah, for a particular era. Nominator slashes in an era, yeah. Hopefully none are there. Yep.
Thank you. So every time a website connects to, let's say, a node, needs first to download the metadata, right? And then from the metadata, it generates the interface
yeah.
to connect. Okay.
That's correct.
Okay.
Yeah.
And this process should be done automatically, or I saw some website asking, validate if you want to update your metadata or not.
Would this be in relation to the extension?
I saw like in Akala, generally, they ask you update your metadata for best experience. Cancel,
gotcha.
Okay. So I don't know.
Yeah. This is generally for web extensions because they're offline. Like, no node is running in the web extension. They only have access to the metadata you provide them. So what Akala and Polkadot.js apps do is they recognize an inconsistency and they'll say, hey, let's update this. The chain is updated. Yeah.
Okay, thanks.
Cool. Okay. Yeah, constructing transactions. So what we've just been through are like the read operations of the chain, of the API. So now let's explore how to like write stuff to a chain. And to do this, we construct transactions. So we have a few ways to do this. The most simple way is to use api.tx. I want to submit a transaction, followed by the palette name and the call. So pretty simple. As an example, I want to bond some amounts, call the bond call from the staking palette here. Okay. We can batch multiple transactions in one call using batch, so utility.batch. So if I want to start staking, I might want to bond an amount, and then I might want to supply my nominations. So the bond call and the nominate call. So batch all is also available. And batch all requires all of the supply transactions to succeed, whereas batch does not. So some can fail on batch. So in the previous example of starting to stake, I might want to use batch all instead. We can also use proxies in the case of the relay chain, or any runtime that supports the proxy palette. So api.tx.proxy.proxy, proxy palette, proxy call. The from address, this null value is, you can force the type of proxy to be used if this from address here is the registered proxy. So there's various proxy types. The staking proxy just allows the proxy account to call staking related calls, for example. So I can force the type of proxy and give it the transaction as well. Like every transaction provided in the batch has to not fail. So extrinsic succeed. It needs to actually process. So like if a failure is returned, then the whole batch of transactions will revert and not pass, like not take effect on chain. Yep. So there's an easy way to submit transactions, and there's a hard way. So the easy way is to use a method called sign and send. Yeah. So the way this works is that, like a subscription, there's an unsub that is returned. I give the transaction I would like to execute, sign and send. The from address, I can give a signer if I want to, which is provided by the web extension. And then I have a result. And every time the transaction status is updated, this callback function again is executed. So I can keep track of the state of the transaction. So from a Dapps perspective, I'm mostly interested in the in-block status. So this happens in around 6 seconds on Polkadot. So we can have relative confidence that this transaction will succeed at this point. So the UI will then be able to refresh and update. So is finalized takes anywhere between up to a minute. So even though it's safer to assume this transaction is actually finalized, the UI is correct, it's not the best user experience. So we usually listen to the in-block status. Okay. So the hard way to build transactions is the process of manually building an extrinsic payload. So we usually do this when a signer is not available from a web extension, for example. So, okay. Yeah. So think of hardware wallets like Polkadot Vault and Ledger. So the signer is on the device. So we cannot get the signer from a web extension or wherever they might be. So what we have to do is we need to prepare the transaction in a payload. We then send the payload to wherever the signer is, in this case maybe a Polkadot Vault or a Ledger hardware wallet, and then they return a signature. They sign the payload, return a signature, and then we can go ahead and then submit the transaction with that signature. So in the case of sign and send, the payload is built under the hood, it's signed, usually you just provide a signer from a web extension, and then it's submitted automatically. Okay. Yeah, so just to reiterate, the flow is, build the payload, we need that signed, and then we can submit the transaction. So yeah, these two words are interchangeable in the Dapps world. Extrinsic means a lot more on Substrate, but the difference between calling something an extrinsic and a transaction on the Dapps world usually just refers to something that we're paying a fee for. So transaction fees, therefore it's called a transaction. So they mean pretty much the same thing there in this context. So I'm not expecting anyone to memorize all this, but this is the boilerplate for a payload. So the takeaway is that we need quite a lot of data to build a transaction payload. So you know the runtime version, transaction versions, block details, era, genesis hash, the methods, the calls we want to interact with, the account nonce, signed extensions. So I think Polkadot has 8 or 9 of these, ranging from like check nonce, check this, check that, extending the logic of an extrinsic. And of course, like the version, transaction version. So you can also notice here that we're using a new API, API registry create type. So when Polkadot.js connects to a node and populates its metadata, it's populating this registry with all the types your chain is using. So here's some overlaps like the compact scale index. There's a type called call, intrinsic era, etc. So these are not to be confused with TypeScript types. These are types from your node. So I just give the primitive JavaScript value here, like my account nonce. I say I want this to be a compact index, and then under the hood, Polkadot.js API will format that to a value the JSON RPC understands. So we don't need to worry about that. Okay. So when we're done creating the payload, we then create an extrinsic payload type using that value, and we build our payload. Okay. So here's an example, practical example of this. So we build a payload using Polkadot.js API. We then convert this payload into some bytes and present it as a QR code. So then we can scan this QR code with Polkadot Vault. Vault will then generate the signature of the transaction. We present it back to our Dapp. And then we can go ahead and send the transaction. So we need both pieces of information in this case, the payload and the signature. So this is just a snippet of code, again, to demonstrate this process. So just a simple balances transfer call. That's the TX I would like to make. Construct the payload, the previous slide. This is constructing the QR code data, some magic numbers explained in the Polkadot wiki, a bit out of scope of this, but it's just a bunch of bytes we're using to create the QR code. So yeah, generate the signature. So this will be the process of interacting with Polkadot Vault. It will give us back a signature. We use tx.addSignature to the transaction, and then we're back to submitting. So instead of sign and send, this time we're just using .send. Okay, so that was a very much longer process than using sign and send. Okay, any questions about that? No? Okay. So Dapp optimization. So yeah, Dapp development is a very agile process, and this is a very simplified representation of how a Dapp is developed. So in the early stages, we're determining which features we would like in our Dapp, what works well, and there's lots of potentials in this step. So we release our minimum viable product. The key here then is to listen to feedback from the community. Is it working as we expected? Is it what the community want? And then there's like a long process of optimization. Okay. So one way we can optimize is by looking at the bundle of our Dapp. So this is a V2 visualizer package, package analysis, and we can determine which dependencies in our project are consuming most of the bundle size. So in this case, this big red chunk here is just one package. It's Substrate Connect, so light client compatibility. So, and all these different colors are images or SVGs and whatnot. So each of these chunks are loaded asynchronously, separately. So what we can actually do is determine which packages are taking up space and then optimize. So in Substrate Connect's case, it is dynamically loaded only when the user opts to use the light client, rather than loading on the initial page load. So this is like 2.5 megabytes, so it's quite a lot. Yeah, local storage is a very useful tool. Staking Dashboard uses it in quite a messy manner currently, but unclaimed payouts is a good example here. So we're caching the actual unclaimed payouts for various accounts, and this is quite a long process. We're fetching various values from the node to determine this. So yeah, it's good for caching heavy computations. Size limit's quite small. We can use this tool here if you like to determine the size your browser supports, but Brave local storage limited to that many characters. Online offline detection, so that's quite interesting. Yeah, so Dapps, we tend to subscribe to query storage items. It's more of a real-time interface, so we need to communicate when the DApp is online or when it's offline. So there's a couple of ways we can do this. There's an API called Navigator Online. We can either query it or subscribe to it, and then our DApp can react. If it goes offline, we can prompt a UI for the user. There's also another way, polling. So every few seconds, I might want to try and contact Google or something to determine if my DApp is online. So why would we do this if we have Navigator Online? Well, Navigator Online sometimes returns false positives. So if I have a VPN turned on, or if I'm using a virtualization software, it might think I'm online, even if my Wi-Fi is turned off. It will be offline in reality, but it will still think we're online. So polling is also important. So how might we poll in a decentralized manner? Can anyone think of how we could do this? So instead of contacting Google every few seconds, how would we determine if we're online when we're just using a node? No? Well, the Babe palette on Polkadot has a const called expected block time. So we know like a block should be produced every 6 seconds. So if we subscribe to the block numbers coming in, and we're like 12, 18 seconds have gone, but the block hasn't updated, we can probably assume the block we're offline. So this is like decentralized polling. So rendering in React. Yeah. Who here has used React.js before? Oh, great. Okay. So, rendering in React is an optimization. It's quite an important one that I'm exploring in quite a lot of detail right now with Staking Dashboard. So to summarize the basics of React, let's say. So React apps are constructed using components, and components are written using JSX markup. Looks a lot like HTML, but they represent components, not HTML tags. So every component can store state, so data that is persisted throughout re-renders. Yeah, and a re-render is the process of the DOM refreshing with the updated UI. So when state changes, components re-render and the DOM is updated. And as a result of this, child components could potentially re-render as well. Okay. Very simple example. 2 components here, my app component and another one called update title button. So I'm defining it here, update title button, and it is being embedded here. This is the JSX code, right? So the state of my app, I only have one state object, title, and in React we have a getter and a setter. And we can pass this setter through our component hierarchy. So in this case, I'm passing set title to my update title button component. So when I click a button in this component, I'm going to call a function to generate another random phrase, and this will update my title in app. Is that clear? Right. And of course, when I call my setter, my state setter, the component re-renders. So if we now consider Polkadot.js API in this scenario, the more subscriptions we define in our Dapp, the more callbacks that will be executed. And more often than not, we want to store that callback data in our React state. So every time a callback is executed, component state is updated. This can lead to excessive re-renders. And this issue is exacerbated the more calls we introduce. So a feature-rich Dapp will probably have many, many subscriptions going at the same time. And this obviously causes a lot of overhead. So eventually, we will experience slowdown, performance issues. On the staking dashboard, on the initial page load, sometimes it stutters and the transitions are not smooth because that initial injection of all the state is causing the slowdown. So we generally want to reduce re-renders as much as possible. So there's various ways we can do this. One simple way is just to initially fetch all the state in one go, like an asynchronous function, and put it in state in one call or one block of set state logic, and then subscribe to each individual storage item. Because when the callback comes in, React will realize it's the same value, and then it will not trigger a re-render. We can also explicitly check if it's the same value as that's in state as well. So yeah, initially populate all the state values in one go, and then subscribe. We have various APIs provided by React to cut down on re-renders. We can cache computations. We can cache function definitions. And another useful thing, use ref, which persists values throughout re-renders, but updating a ref does not trigger a state update and a re-render. So like the unsubs are a good example of what we can persist to use ref, because the UI doesn't care about unsubs. Okay. There's no need to re-render if an unsub changes. So two very effective ways, though, to prevent re-renders is only store things in state that the UI needs. And another way is to just not use React. Just subscribe to your API calls outside of React, and then trigger something like custom events to deliver some data to React, which it can then respond to. So, only use state required for UI updates. So here's a few examples of what React actually cares about for state. So the network I'm on, so I might want to re-render my network colors, my logos, etc. when that changes. We don't really care about the provider or the API instance, because again, it doesn't affect the UI, what is being displayed. So these could either be refs or they could just be outside of React. Yeah, the connection status, that's quite important because I want to provide user feedback. Yeah, and when the API is ready to be used, when it's ready to be interacted with, I might want to enable some buttons that have been disabled and stuff like that. Okay. Another interesting way is to just decouple subscriptions from React completely. So this is a really good way to just separate concerns completely. So I might have a static TypeScript class that manages my subscriptions, and within the callback function, I can dispatch an event to the document. So result.toHuman, formatting our results, and then on the React side, I can go ahead and subscribe to an event listener, and then update state in this component only. Okay. Okay. So miscellaneous mentions. So we haven't covered XCM yet, but there are some tools in the JavaScript, TypeScript world to interact with XCM. So Parity have a package, Asset Transfer API, that's focused on transferring assets across chains. And then there's a newer one from Paraspell that is more general purpose, XCM SDK, let's say. So these are two good resources if you're interested in creating multi-chain dApps. Okay. Yeah, using AI, I wanted to touch on this as well. So ChatGPT is pretty useful for dApp development in general. So especially for, say, Node.js, like using the file system, it's like tedious code, you know, like tedious blocks of code that we need to write. You know, we can just ask ChatGPT to give this to us. And if in your existing code bases as well, you can just ask it to, you know, can you make this code more efficient or simplify it? And more often than not, it will give us some more simplified version of, more readable version of our code. Yeah. And if you want to be more adventurous, we can also, you know, the latest models are trained with, the latest models were, you know, quite recent. And now Polkadot is you know, a lot more proficient than it was 12, 18 months ago. So ChatGPT is in a better position today to provide like an in-app assistant as well. Okay. GitHub Copilot. Yeah, is anyone using this today? No, a few people. Okay. Really useful in the JavaScript and TypeScript world. Frame and Substrate are quite niche, and predictions might not be so accurate. They are very accurate with JavaScript and TypeScript. JavaScript being the #1 programming language, period. Number 2 is HTML, I think, and number 3 is Python. So TypeScript is 5. So models are very accurate now at predicting code, and Copilot does a good job. So yeah, it can predict code as you write it, sometimes with very impressive accuracy, and also provides solution to errors and can help you out in that way. Yeah, like image generation like DALL-E or Midjourney can be used to generate dApp interfaces, pretty useful for conceptualizing interfaces. And Illustrator now provides this AI prompt service to generate artwork. So I can just type in what I would like to see, and it will generate it in SVG format. Pretty useful. So I think it can generate scenes, icons, like subjects, and patterns as well. So that might be useful. The negative of this is that it will become very easy to mimic or fake dApp, so social engineering attacks. So just remember, not your keys, not your coins. If interface is asking for your seed phrase, like never do that. Okay, questions? I don't think so. Is it on?
Give me a mic.
Should be working.
I don't feel like it's working as well. Test. Okay, it's working? Yeah. Okay, so let's say I'm like Amazon, and I'm building a dApp, and I've done all the testing, all the QA, whatever, and then there is a runtime upgrade, and now my app is broken. How do we mitigate that in the Polkadot ecosystem? Because there's no way for Amazon to do anything about that.
If your dApp has a runtime upgrade.
So like I have a dApp, I test it,
Yeah.
and then the chain has a runtime upgrade, right? And
Yeah.
then like my app it's just broken now, and there's nothing
Exactly.
I can do. So and I have like millions of customers. So what's the workaround?
I think the best thing we can do is read that metadata and read the spec version from the API, and if it doesn't match with your expectations, flag a UI prompt, say like the app is currently outdated, kind of thing.
Yes, but
Yeah.
like if you have a mission critical app and you have millions of customers and just say like, oh, my app just doesn't work now, it's like really bad, right? Like what is the future, like what's the plan forward for like that?
Yeah, when we're developing palettes, we tend to be very conservative about changing public APIs. So the frame developers have a responsibility here not to roll out breaking changes, period. Only if it's really critical. Like one of the challenging things we've done recently is controller account deprecation for staking, which had breaking changes. So like months in advance, we let the UIs know, explain exactly what is changing, so they're prepared. When it rolls out on the test net, like West End, they can test their UIs, and then usually months later, like 1-2 months later, we roll them out on the main nets, and they're prepared.
Yeah.
So this is probably
Makes sense.
it's
Okay.
an offline effort, I would say. Yeah. Any other questions? Nope. Okay. Thanks for listening. Oh, there's one more question. Sorry.
Yeah, so my question is on the subscription and also re-rendering.
Okay.
So for example, you are watching on changes of some storage item, right?
Yeah.
And you be like, if this changes, right? If maybe you're watching an array, if this array is populated in the chain storage, I need to render a component with the values of these storage items, right? So you're waiting on some vector, and it means like when something is pushed in the vector, it means it renders new component, then another one like in vertical. One issue is okay, I was trying to use Memo in a way that I don't want to re-rendering like in other components. I just want to listen to it, fetch it, and then update my use state. And then after updating my use state, my component looks into use state and then renders based on update of use state. But then it doesn't really work. It has some issues on that. So how do you advise in terms of how can I make sure that I only render once I receive? I'm listening, of course, subscribing. Once I receive, I update my use state, and after updating my use state, I want to render the components.
Yeah, use effect comes to mind. I'm sure you've tried use effect already, but maybe we should look at it offline.
Yeah, sure, for sure.
Yeah.
Thank you.
Okay. Okay. Thank you.